Welcome to Through Inquisitive Kids, and in this video we will be learning how to multiply monomials. And so here is our course outline for Unit 7. Our learning goals for today is to master how to multiply monomials, and we're going to be able to apply it to actual expressions flexibly. What are the laws of exponents that we learned before? Do you still remember them? So we learned a to the nth power to the nth power equals a to the m times nth power. And the product of ab to the nth power equals a to the nth power times b to the nth power. And the quotient of powers. A to the nth power divided by a to the nth power equals a to the m minus nth power. So I want you to simplify the four following expressions. For the first expression, we have negative a to the 25th power. So in this case, we used the first law over here because 5 times 5 equals 25. For the second problem, we get a to the 6th power times b cubed. So this negative a squared over here is actually the same thing as a squared. Because a negative number squared, for example, negative 1 times negative 1 equals 1. That's the same thing as its positive counterpart, which is 1 times 1 equals 1. So it's the same thing. So basically we have the product of a squared in b to the third power. And then we use this second law to get a to the 6th power times b cubed. For the third problem, we got negative 108 times a to the 8th power. Because for the first monomial, we got 4 times a squared. And then we used this equation over here to solve for the second monomial to get negative 27 times a to the 6th power. And so negative 27 times 4 equals negative 108, and a squared times a to the 6th power equals a to the 8th power. And lastly, for the fourth problem, we have y to the 3n minus 1th power. For this section, it's the same thing as negative y to the second power to the nth power. Basically swap this n and the 2 around. It's still the same thing. So basically it's the same thing as positive y to the 2nth power times y to the n minus 1th power. And since their bases are the same, they're both y's, we can add together the exponents to get 3n minus 1. Several identical TVs are stacked together to form a TV wall. Calculate the area of this TV wall in the picture. We can see that the TV wall is a rectangle. There are actually two different ways to look at this. You can represent it as 3a times 3b or 9ab. They're basically the same thing. You can look at it as an entire big rectangle. The length is 3a and the width is 3b. So the area would be 3 times 3b. Or you can look at it as 9ab. There are 9 smaller rectangles that's the same, and each little rectangle is an AB. And there are 9 of them, so it's 9AB. Since we know that the area of the entire rectangle does not change anyway, 3a times 3b equals 9ab. They all represent the same thing. Janet drew 2 separate pictures with 2 pieces of identical paper. The first drawing with the sun is the same size as the entire paper, so it takes up the entire paper. And the second picture does not take up the entire paper. It has 1/8 meter wide blanks at the top and bottom of the paper. So the question is, what was the area of the first drawing with the sun? What about the second picture? And what expression would you write to represent the areas? The first problem is easy. We just multiplied together the side lengths. So we have 1.2x times x to get 1.2 times x squared. And for the second drawing with the leaves, it's 3/4 x times 1.2x equals 0.9 times x squared. We already know that the length is still the same, 1.2x. But the width is actually 3/4 x. Because 1 whole minus 2/8 equals 3/4. Simplify these two expressions. For the first problem, we switch the order of the variables and the coefficients around. So we put the coefficients together, and then we grouped the same variables together, and then we multiplied. So the coefficients multiplied together equals 6, and then the exponents with the like bases gave us x cubed times y cubed. And for the second problem, it's the same thing. We put the coefficients together. Negative 12 times a to the 5th power times b times x to the 6th power. So we use the commutative and associative law of multiplication to switch the orders around and group them together. You can combine the coefficients and multiply the exponents with the same bases together. You might also have to use some of the laws of exponents. Be sure to remember the sign that's in the coefficients. Is it negative or is it positive? Here's some practice. I want you to calculate and simplify the following 3 problems. For the first problem, we put the coefficients together to get 2/3 times x squared times y squared. For the second problem, we get 6 times a cubed times b cubed. And for the third problem, you first have to simplify the second monomial. So you got 4 times x squared times y squared times z squared. And then you apply our method. We times 7 and 4 together to get 28. And then x cubed, y to the 4th power, and z cubed. And again, we use the commutative and associative laws of multiplication to multiply monomials. For the first problem, we have 9 times x squared times 4 times x squared. We put the coefficients together to get 36 and the variables together to get x to the 4th power. For the second problem, we have negative 72 times a to the 5th power. And for the third problem, we have 3 monomials. But it's still the same thing. We put together the coefficients and the exponents with the like bases. So our answer is 20/3 times a cubed times b cubed times c to the 9th power. Example 2. There is a rectangular open space with a length of x meters and a width of y meters. Now plan a rectangular open space with a length of 3/5 x meters and a width of 3/4 y meters for greening. Find the greening area and the remaining area. First, we have to find what is the area of the entire rectangle, and that would be xy meters squared. The area of the greenery is 3/5 x times 3/4 y, which equals 9/20 xy meters squared. And when we subtract the area of the greenery from the area of the entire space, we get 11/20 xy meters squared. Here is actually a harder problem. So the product of these two terms are like terms with x to the 4th power y. Find the value of m squared plus n. So we have these two terms multiplied together, and we know that their product is a like term with x to the 4th power y. So first, what is a like term? We know that like terms, for example, if we have 2xy and negative 7xy, they are like terms because the variable part is the same. And it means that we can add and subtract them together. So we'll get negative 5xy. So for this expression, we first have to combine the exponents with the like bases. We first combine coefficients. 2 times 7 equals 14. Then the x variable. We have x to the 3m plus 1, and then plus 5m minus 3 power, times y to the 2n, we see the 2n over here, plus 5n minus 4th power. So since when we're talking about like terms, we don't really have to care about the coefficient part, so we can ignore the 14. All we know is that x to the 3m plus 1 plus 5m minus 3 power times y to the 2n plus 5n minus 4 power equals x to the 4th power times y to the 1 power. Since these two are equal, it means that their exponents are equal. So for the x exponent, we know that 3m plus 1 plus 5m minus 3 equals this 4. And the y variables, 2n plus 5n minus 4 equals this 1. The 1 is not showing. Now since we have these two equations down, all we have to do is to solve for m and n. So the first problem, 8m minus 2 equals 4, which also means that 8m equals 6. And so m equals 6/8, which is the same thing as 3/4. And n is the same thing as 7n equals 5. Now we're going to divide 7 on both sides to get n equals 5/7. Now we know what m and n equals. So now we can solve m squared plus n. Here's a harder problem to expand your thinking. These two terms multiplied together equals a to the 5th power times b cubed. Find the value of m plus n. We have a to the m plus 1th power times b to the n plus 2 power times a to the 2n minus 1 power times b. And this equals a to the 5th power times b cubed. For the a's, since they're like bases, we can combine them. So we have a to the m plus 1, and we're going to combine their exponents. So we're going to add the 2n minus 1 to it, 2n minus 1, times b to the n plus 3 power. And this gives us a to the 5th power times b cubed. So now we're going to zoom in to the exponents part of this equation. We can see that the a exponents, m plus 1 plus 2n minus 1 equals 5, and n plus 3, this is the b exponents, equals 3. So now since we have these two equations down, we can solve for m and n. This equation can be converted into m plus 2n equals 5. So we don't know what it is yet. Now let's move on to the b exponents equation. From this we know that n equals 0. So since we know that n equals 0, the n over here is also a 0. And so this entire thing we can cross out. So m equals 5. Now we know that m equals 5 and n equals 0. So first we multiplied the exponents with the like bases together. So we combined the a's and the b's. So we combined a to the n plus 1th power and a to the 2n minus 1th power together to get a to the m plus 1 plus 2n minus 1th power. And for b, we have b to the n plus 2 plus 1th power. And the problem tells us that it equals a to the 5th power times b cubed. And now we zoom into the exponents. We know that the exponents of a, m plus 1 plus 2n minus 1 equals 5. And the exponents of b, n plus 2 plus 1 equals 3. And we know that m equals 5 and n equals 0, which means that our answer is 5 because m plus n, because 5 plus 0 equals 5. Our summary for today is the laws of exponents that we learned earlier will be really useful in multiplying monomials. First, combine the exponents with the like variables, with the like bases, and then do the rest of multiplying with the coefficients.